Roulettesystem GewinnErfolg Roulettesystem. Author Dr. D. Selzer-McKenzie. 1. Introduction. This is a report on the findings of Stage 3.1 of the project proposal submitted by Selzer-McKenzie Laboratories to SelMcKenzie on the 24th of February, 2001. 2. Background. It is understood that a roulette wheel can become biased, either through wear of the rim or tilting of the wheel, so that the ball will fall towards the center at a reasonably predictable fixed area of the stationary part of the wheel, known as the drop zone. Any wheel will exhibit this bias if sufficiently tilted, but the necessary angle of tilt to cause this is not known. As NWML already owns calibrated digital tilt measuring devices, inclinometers, the following proposal was made to test for the effects of tilt on a wheel. Adjust the level of the wheel until there is no bias, i.e., there is no regular drop zone. Measure the angle of tilt, if any, of the wheel in this position, to determine whether simply leveling the wheel accurately would result in a lack of bias. Tilt the wheel from this position, in at least 4 different directions, until regular drop zones are produced. Consider whether a spirit level is sufficiently accurate to determine whether an installed wheel will be biased, if simply leveling is found to be sufficient. 3. Method and results. A modern roulette wheel, in excellent condition, was received from TCS Huxley. The roulette wheel was mounted onto a tilt table which is normally used for tilt testing of weighing instruments. The table allowed tilting of the wheel in any direction, up to a maximum angle of 1.35 degrees. The proposed method outlined above was modified slightly such that the tilt table, roulette wheel, was set so as to be level, and small angles of tilt could be measured on parts of the table as shown in Annex 1. The outer rim of the roulette wheel was then divided into 8 equal segments, see Annex 1. 176 spins of the ball were conducted, with a record made of which segment the ball fell into on each spin. The ball was introduced to the wheel at the same point, segment 5, for each spin on this test and for all subsequent tests. Table 1 shows the results of this initial test. By applying chi-square analysis to the results, x2 equals 3.36 with 7 degrees of freedom, it was determined that the probability that the measurement results were down to pure chance, i.e. random, was approximately 85%. The tilt table was then tilted to give the maximum tilt of 1.35 degrees in one plane, right to left when viewing the wheel as per Annex 1. The test was repeated, with Table 2 showing the results of this test. Chi-square analysis of these results, x2 equals 64.1 with 7 degrees of freedom, indicates a probability of less than 0.1% that these results are down to chance, i.e., there is a greater than 99.9% probability that the results are due to a bias on the table. The angle of tilt was then reduced to 0.5 degrees, 0.25 degrees and then 0.1 degrees. Again, the tests were repeated at each of these angles of tilt. A chi-square analysis was made of each set of results. These results are shown in table. The table was then tilted to an angle of 0.1 degrees in the other 3 planes. Only 80 spins were conducted for each of these tests. The results are shown in Table 4. A check of a typical standard spirit level, obtained from a DIY store, showed that a 0.1 degrees angle equates to the bubble just touching the first indicating line on the bubble window as shown in Figure 1. 4. Summary of results. The results indicate that when the wheel was level, it should be noted that a certain amount of tilt was discernible on some parts of the tilt table using the digital inclinometer, a figure of 85% probability that the results were down to chance, i.e., random, was achieved. It is possible that this figure could be improved to the more generally accepted 95% level by making very fine adjustments to the tilt table to ensure that it was perfectly level. However, it was decided not to chase perfection, as these initial results indicated a good benchmark with which to compare the results of the tilt testing. Tilting the wheel to 1.35 degrees led to a greater than 99.9% probability that the results were the result of a bias on the wheel. Reducing the angle of tilt reduced the probability figure, but even at an angle of only 0.1 degrees, a probability of 98% that the wheel was biased was still obtained. The results in the other three planes gave repeatable results, with the lowest probability still in the region of 98%. An analysis of the peak segment numbers also indicates that the bias appears to move in relation to the plane in which the table is tilted. 5. Conclusions. It appears from the results of testing that an angle of as little as 0.1 degrees, the first line on the bubble window of a standard spirit level, will introduce a bias into the wheel. It can also be seen that the bias will vary according to the plane in which the wheel is tilted. A tilt of only 0.1 degrees could be easily introduced if the wheel is not mounted correctly, if the mounting or the table is not stable over time, or by leaning on the table on which the wheel is mounted if it is not sufficiently rigid. It therefore appears essential from these initial findings that particular attention should be given to the tables in the casinos into which the roulette wheels are mounted. It is suggested that calibrated digital inclinometers be used when mounting the wheels, although it can be seen that a standard spirit level can indicate quite clearly a tilt of 0.1 degrees. The tables should be sufficiently rigid and stable over time and not be liable to tilting by someone leaning on the table. Stability over time could be ensured by regular checks of the level and adjustment if necessary. As it can be seen how easily a bias can be introduced, the next two stages of the project can now be undertaken. These will begin upon receipt of the roulette prediction device and software from Selzer-McKenzie. Part 02. 2. Background. A number of individuals, most notably Selzer-McKenzie of ServTech and SelMcKenzie of MH Technologies, claim to have developed roulette prediction devices that will provide the user with an advantage over the casino when gambling on roulette. Selzer-McKenzie claims that his prediction device can give a return of 20% on turnover over a period of time on a biased wheel. This relates to a win once in every 6 spins when betting on the predicted number and neighbor's predicted number and the two numbers either side. SelMcKenzie claims a better return, even on a wheel with no tilt. Selzer-McKenzie was contacted with a view to him loaning SelMcKenzie one of his prediction devices, software running on a modified IPAC, for the purposes of this evaluation exercise. The following proposal was made to determine the effectiveness of the prediction device. Adjust the level of the wheel to introduce a bias, i.e., a regular drop zone, and use the prediction device to attempt to predict the outcome. Section 3.2 of proposal. Adjust the wheel so that there is no discernible bias and use the prediction device to attempt to predict the outcome. Section 3.3 of proposal. NB. During this stage of the project, SelMcKenzie contacted SelMcKenzie requesting that we certify his device. I responded to him that we were unable to endorse or certify devices of this kind. He also